Here's problem 5. It tells you a whole lot more information to it on the problem, but I didn't have enough room to write all those things for you. So basically the problem is saying, hey, here's the equation you and I have. It wants to know what's the y-intercept, what's the vertex, and what's a third point that must be on this guy from knowing the vertex and the y-intercept. Well, let's start with the y-intercept. That's pretty easy to find. What you and I have here is we know we have a parabola. It's an upwards facing parabola, so we know it's basically a U like this going up. Of course, it's not exactly straight up going out. So let's imagine what you and I have. We basically have this graph, and this guy's hitting somewhere on the y-axis. It's coming down here. Maybe it's touching and shooting back up. Maybe it's going through 2 points. I don't know. But I got a point on this, a y-intercept point right here. Now, what do we know is true about the y-intercept? Well, we know that you've gone over nothing. The x value is 0. Well, if the x value is 0 and 0 there, what do you and I have? We have a height of what? 13. So this guy must be located, because if we're on the y-axis, y-intercept, the x value's got to be 0. If I plug 0 into that equation, I got 13. You just got to sort of block that part out there. So I know that I've got it right here at 0, 13. Now it's going to swing down, and again, I don't know if it's going to touch or whatever, but who knows what it's going to do. Maybe it swings down here and hits. Let's just pretend that that's what happens. I want to figure out this other point maybe over there, which I know will be at something, comma, 13. But it wants me to find this vertex down here. Well, how can I find the vertex? Well, what do I know is true about the tangent line right here? That tangent line is going to have a slope of what? 0. What equation gives you the slope at any point on this parabola? The derivative of that. The derivative of that equation right there of x squared minus 6x plus 13 will tell you the slope at any point right here. Well, I want to know when that slope comes out to be right in that one location, slope of nothing, slope of 0. So if I take the derivative of this, that's going to be 2x minus 6. And I want that derivative to have a slope of 0. So it would be right there. Looking at this very quickly, you can move 6 over, but you can see it's going to happen when x's value is 3. So I know what happens when x is right there at 3. Now I don't know where the y value is. How can I figure out what the y value is? I know the vertex is at 3 comma something. How can I figure out where it is? Plug 3 into the equation. 3 squared is 9. 9 minus 6 times 3, 18. 9 minus 18 is negative 9, plus 13 is 4. So this happens at 3 comma 4. So I know that actually doesn't occur down here. It's going to occur up here at 4. And actually in the equation, in all the stuff that you see on the homework there, I did mention this doesn't touch the x-axis. Forgot about that, but so I do know it hits right up here. So it's swinging, hitting there, and then going here. Well, how do I find that point? Well, I don't know. Let's see. It's a third point. Well, let me think for a second. Parabolas are perfectly symmetrical. Whatever happens from what's called the axis of symmetry, which in this case is right down the center here at 3 where the vertex is, whatever happens on however far apart points are from this guy, they're the same distance on that side. Well, think about it. This was at 0, 13. Over here to 3, 13. If I jump 3 more, that's going to be from 3 over, it's going to be 6, 13. There's got to be a third point at 6 comma 13. I know that has to happen. Again, the axis of symmetry is right here at 3. I had a point here at 0, 13. So I know from here over to that axis of symmetry is 3 hops. So if I'm at 3 and I go 3 more hops over, with 3 hops over is at 6. This guy's going to be at 6 comma, same height, 13. There you have the y-intercept, the vertex, and a third point on that parabola.